Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. Today we'll be solving another Leetcode problem on binary search. So let's see what is the problem. So the problem is called find peak element. So you will be given an array. So you'll be given an array, and in that array you have to find peak element. What is meant by actually peak element? So here you can see 3 is a peak element. Means in the left and at the right, so what is adjacent left and adjacent right element should be less than our peak element. That is the condition. So to become a peak element, so left and right should be lower value than that. And here is one another condition is given. So there will be no such element that are equal to the neighbor. So let's say here we have 3. So in beside 3, so in the left there 3 couldn't be repeated again, or in the right, so there 3 couldn't be repeated again. This is the main key here, right? And let's say 3 is presented at the right. 3 is presented at the right. Okay, then you can see at the right. So let's say what is basically a peak element. Let's say we have 3 element. Okay, let's say 1 2 3. Sorry, 1 2 3. So 3 is the last element here, right? 3 is the last element here. So at the right of 3 there is no such element, but in the left we can see 2 is less than 3, right? So that's why 3 here will be an peak element. 3 will be here an peak element. So in that array, so they are given an example. So here you can see this 2 is a peak element. This 6 can be also a peak element, right? So in the 6, the left neighbor and right neighbor is less than 6, and for 2, left neighbor and right neighbor, that is also less than peak element, right? So to become a peak element, so peak element should be like this. So array would be look like this. So this could be one peak element, this could be one peak element, this could be one peak element, and there may be another elements here. Okay, there may be another elements here, but we have to find any of this peak element. We have to find any of this peak element. Now to find peak element, what is the condition? So what is the condition? So if we apply binary search, so let's say this is our low, this is our high, this is our high, and what we gonna do? We gonna find middle node here. So what are you gonna do? Every time we're gonna find middle node. Okay, and in that middle node we'll compare. Let's say this is our middle node. Okay, this is our middle node. Okay, now what condition it should be satisfied to become peak node? The condition should be the left element and the right element. The left element, if it is present, and the right element, if it is present, that should be less than this current element. This is the condition. This is one single condition here. Now here you can see the left element. What is this? This one, right? So this element is not less than this. So this couldn't be our answer. Now let's say our mid element is this one. Our mid element is this one. Okay, this is our mid. Now if you see the left element and the right element here, in the left element and right element is less than the mid element, right? Is less than the mid element, right? So if we find such mid node, that will be our answer, right? But if that node is not a mid node, let's say our array is like this. So these are some elements. So let's say this is 5, this is 6, this is 9, and this is 12, right? Like this. And let's say our mid node is this node. This is our mid node. Okay, this is our mid node. Okay, now the left of mid node, is this less than mid? Yes, right, it is less than mid. But the right node of this mid node, is this less than mid? No, right? No, right? Now tell me what we have to do. Now tell me, in this portion should we find the answer, or in this portion should we get the answer? In which portion we have to move? Obviously where we found the greater element, that could be our possible search phase, right? That could be our possible search phase. Yes, might be there's some element like here. Here we can find some element, but we have to return any of this peak, right? We have to return any of this peak. So if it is 6 and if we have find a greater element to 6, that means we'll sure that 9 could be one possible answer, right? 9 could be one possible answer, but the 6, but this 5 couldn't be answer, or 6 couldn't be answer, because greater than 6 there is already a element present. So what are the else conditions here? So if we don't find any mid nodes such that the left element and right element are less than that, then whichever the greater element we have found, whichever the greater element 5, we have to search in that way. We have to search in that portion only, right? So what are the condition? What are the condition? Let's write it. So if, so let's say we have find a mid node. Okay, we have find a mid node. Now we'll be comparing with the previous one, right? So error of m minus 1, if it is less than error of m, okay, and another is error of m plus 1, if it is also less than error of m, then only what are you gonna do? This is point number 1. Then what we gonna do? We're gonna return this m, right? This middle node. That is our expected answer. Okay. Then point number 2. Let's say error of m minus 1. This is greater than error of m. Okay. This is greater than error of m. Whenever we found a greater element in the neighbor, that means there we could found an answer, right? Then what we'll do immediately, so that means we have to search in the left hand side, right? So we'll move our high to m minus 1, right? And else, in the else condition, what are you gonna do? We're gonna move our low to m plus 1. So that's it. This is the case, right? So to find the peak, what is the condition? The leftmost element and rightmost element should be less than our current element. Okay, here one thing we have to consider, like if our middle is at the beginning, okay, let's say at index 0, then what are we gonna do? We avoid comparing the previous element, right? We can avoid comparing the previous element. And again, if we at a end of the array, then we can avoid comparing the right element, right? So let's see how we can write the code. So first thing, let's take a low pointer, it will like 0. Let's take high pointer, it will be length of the, sorry, not nums minus 1, sorry, minus 1. Then what are you gonna do? You're gonna write a while loop. Condition is low while less than equals to high, right? Then we'll calculate a mid node. Mid equals to low plus high minus low, float divided by 2. Then we'll write the condition. So what is the first condition? If so first we have to check if m equals to 0, then we'll be avoiding this thing, right? So or nums of the previous element m minus 1, if it is less than nums of m, right? This is one condition. And what are the other condition? If m equals to that length of the nums minus 1, right? This is minus 1. Let's put inside a bracket. And or this nums of m plus 1 is less than nums of m, then what are you gonna do? This is our first condition. Then we'll just return what we have to return. We have to return the index, right? So we'll be returning m, sorry, m here. And else if m is greater than 0, right? If m is greater than 0 and the previous element is greater than nums of m, then what we'll do? Then one possibility could be the peak is in the left hand side, right? So what we'll do, we'll move our high pointer to m minus 1. And else what are you going to do? We're going to move our low pointer to m plus 1. Okay, so this is the code. And at last, if we didn't find anything, let's return minus 1. Okay, let's run that and let's see. Okay, it is accepted. Let's try to submit. Yeah, it is accepted.